Computer networks are like highways. The smoother the flow of information, the faster we can create the future. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Sirzi Islamifati. I come from a high school in a certain city, specifically in class 12.6, or in its position in the independent curriculum, which is the class for informatics. This time my video is about how to convert decimal numbers to binary numbers, and vice versa, how to convert binary numbers to decimal. I guarantee that this method is very easy. Before that, we need to understand what it means to convert these numbers. So this is part of how computers and digital devices work, because they think in binary numbers. Before we discuss how to convert binary numbers to decimal numbers, or vice versa, we need to understand that binary, or base 2, is a number system that only uses 2 digits, which are 0 and 1. This system is used by computers to process information, as computers operate with electronic circuits that recognize only 2 states. The first is on, and the second is off or 0. The second is decimal or base 10. Decimal or base 10 is the number system that we usually use in our daily lives with 10 different digits. Alright, we will proceed to the method of solving with the following two problems. Each of these has 4 ABCD. For the first problem, perform the conversion of decimal numbers to binary. The first, a 115, the second, B124, the third, C172, and D168. Okay, friends. Here we will start with the example questions for our discussion or our main example. Now, before we start from decimal numbers to binary numbers, there are very important things you need to pay attention to or remember, or you must understand. Now here you need to remember that the bit we are using is important. 12864321684421. Well, before 128, it is usually 256 because here we are using 8 bits. Why 8 bits? Let's count 1, 2, 3, 4, 5, 6, 7, 8. Since we are using 8 bits here, we start from 128 down to 1. In addition, you must remember this because this is 8-bit. And you also need to keep in mind that this is the most important thing. Later, in the process of addition, if we can use those numbers to add, we must make it 0. Sorry, I mean it should be 1. When it can be used or added, we must mark it with the number 1. So what happens if they cannot be added or if the result exceeds the limit? So what if the result is excessive or unusable? We can simply write it as 0. It's actually quite easy, and I am also a beginner who doesn't really understand. But if we keep practicing, we can do it. This is actually just a logic game, friends. Okay. Earlier we talked about the clusters. Oh, good. Here we have the appreciation. When we choose option B, which is 124, how do we do it? Well, we need to pay attention to the pattern. Here, we need to write down the bits first. There is 128, 64, 32, 16, 8, 2, 1. Now here you have written the bits in this sequence, as you can see clearly and distinctly, and in this particular order, which is evident from the sequence. Now after that, we input the decimal number, but we don't align it. If it is possible, place the decimal number right here exactly. Do not go below 128. Do not go below 128, but next to it is 128 and below that again. Now let's move on to the method. If you find math difficult or you're weak in it, just go ahead and open the calculator. So, how do you do it? Here is how this addition can yield the result of the number 124 in a simple manner, step by step and clearly. Well, for example, we can add 64, 32, 16, 8, 4, 2, and 1. Well, we don't know what the sum is. So, here's how to find out. Let's open the calculator first to make it easier for us. Now we can start right away. The method is that 128 is definitely more than 124, so it is considered excess. Therefore, the rule here is that because it is excess or cannot be used, it is 0. So here we write it with 0. Now what about 64? Is it more or less than 124? Yes, less than 124. That number can later be used or added. So we write 1 accordingly. Example here. Next, here we have 6.4. Now, we need to add. We add 4.6 and 3.2. What is 6.4 plus 3.2? 9.6. Well, that means it can still be used, 9.6. 9.6 is below 124. It can still be. So we write 1 here. We write 1. Now, let's add 3.2 plus 16. Sorry, I meant 6.4 plus 3.2 plus 16, which gives us 9.6. We continue by adding 16.96 plus 16. So, 9.6 plus 16. 112 can still be used. We write 1 here. Now, let's try adding 112 with the number 8. The result can still be 120, which is below 124, just 4 less. So it can be used here. It's simple. Here it is already 120. So how much is it lacking? Yes, it is lacking 4. Is there a number 4 here? There is a number 4 here. So we will input 1. And the result is add 4. Yes, 112. 4, we have it here. 124. So we have written 1. Now, what about 2 and 1? It can't be 124 plus 2. Add 1, that's impossible. That would exceed 124, so it can't be done. If it can't be done, then what can be done? Yes, like the general things I have already given, or things you need to remember. If it cannot be used, we write 0. It's just that simple. So how is it, bro? What's the result? We're also unsure, bro, what the outcome is. Well, here's the result. 0, 1, 1, 1, 1, 1, 0, 0. Here it is. The result is very easy, isn't it? This is already easy from decimal to binary. Moreover, converting binary to decimal is easier. Alright. Let's move on to the next tutorial. The second problem is to convert the binary number to decimal. The first one, which is A, is 11,000. The second one, B0010101, C0010101, and D0010101. Okay, friends, now it's time for us to convert the numbers that have been in decimal to binary. Now we are essentially converting this number from binary to decimal. Yes, how do we do that? Here we take an example where, yes, there are 1111 4 times and 000 4 times. So how do we do it here? Well, we have to remember that I mentioned earlier how the arrangement of bits works. Here, we chose 8 bits. So how do we go about it? So there are 8 bits. How much does that make? It means there are 1, 2, 8, 6, 4, 3, 2, 16, 8, 4, 2, and 1. So how do we start? Here, we just need to break it down first. We can go straight to it. 1, 1, 1, 1, 0, 0, 0, 0. Yes, what comes after that? After that, how many bits do we input, friends? Well, earlier we had 8 bits. So at the beginning, we follow the usual order as usual. So what is this? Yes, this was 1, 2, 8, 6, 4, 3, 2, 16, 8, 4, 2, 1. Okay, friends, so what do we do now that it's like this? Well, here's how to do it. Everyone, each and every one will be carefully and meticulously summed. So what about the 0? Is it not counted? Well, we won't sum the 0, my friends. So we don't need to include it, or we don't need to count it. It's not counted for us. So here, the number 1 means there is 128, 64, 32, and 16. So how is it? Here we have 1, 1, 1, 1, and this is how we add them up. Let's just break it down. So there is 128, 64, 32, 16, 128 plus 64 plus 32 plus 16. What is the result? So what about 8, 4, 2, 1? Why are they not added? Because this is called 0. Now 0 here is said to not be counted. So what is counted is 1. After that, let's focus on the result. We had 128, 64, 32 plus 16. Now let's continue to calculate, friends. So, continuing, we have 128 plus 64 plus 32 plus 16. What is the result? The result is 240. If the result is yes, if the result is 240, okay, friends, it's easy, right? And what if it's not added? How about that? What if we arrange the numbers like before? How about that? Well, here's how to do it. Next, 128, 64, 32, 16, friends. Okay, isn't it easy? Great. All right. It's easy, isn't it? Okay, that's all for today's tutorial. I hope we can meet again on another occasion. Before I conclude, I have a poem for Mr. Ronnie, my informatics teacher in class 12.6. The roses by the edge of the garden. Beautiful, blooming in the morning. Thank you, Mr. Ronnie, the kind teacher. Informatics has become easy for us to learn. Peace be upon you and God's mercy and blessings.